All right, in this video, this is part 2 of solving some linear equations involving fractions and potentially some decimals. We're on the application types of problems now. So let me shift to the next page. All right. So here's what we got. We are going to do a problem where you got water flowing in from two different pipes, but they don't flow in at the same rate. Okay, so it says we have a work formula when two people / machines are working together. So here's kind of a look at it, that you have the rate of kind of person A or machine A, all right, and then you have a time associated with person A, and then you're going to add the person B has a different rate and a different time, and that makes one completed job. Okay, because they're working together, or the machines or the water is pumping water in, they're working together. So you have a rate and a time. And so this rate and time, if the last video, your rate and time put together represents your work. Okay, so really you're talking about work from person A plus work from person B equaling the one completed job. All right, so we got to get some information. We got to put this stuff together. So probably, basically, you're adding the work from one person with the work of the other person completes the job, but you're going to probably have to break it up into individual pieces. You might be missing one and so on. Okay, so we got pipe 1 fills the tank at 6 minutes, and pipe 2 fills the same tank in 8 minutes. So pipe 1. Okay, we have one tank. So that's your job, equals some sort of a rate. Okay, pipe 1 times time, so 6 minutes. All right, so that is, there's a rate times the time equals your job, this work. Okay, so it says that 6 minutes times some sort of a rate to fill up one tank. So we could bring that 6 minutes over and say that our rate is going to equal to 1 over 6 per minute. Okay, so that's the rate. So we're doing 1/6 of the tank per minute. For 6 minutes would fill the tank. All right, so pipe 2 fills the same tank. Pipe 2 fills the same tank in 8 minutes. So one tank that has a different rate, pipe 2 times 8 minutes. So if you solve for R2, you would divide that over, so that would be 1/8 of the tank per minute. Okay, so we have a rate for pipe 1, we have a rate for pipe 2. It says, how long does it take for both pipes together to fill the tank? All right, so here's where the real math kicks in. So together, we have our rate 1 times the same amount of time plus rate 2. Okay, so those times are exactly the same. And then that's going to equal one job. So this is the work of pipe 1 plus the work of pipe 2 equals filling the tank, one job. So we know that the rate of pipe 1 is 1/6 times time, plus the rate of pipe 2 is 1/8 times time equals our one job. All right, so here's where we can clear out fractions. If you want, you can absolutely get common denominators, put the fractions together, whatnot. But you can also clear out fractions, would make this job a lot easier to deal with. So between a 6 and an 8, our common denominator is going to be 24. These common denominator is 24. So I'm going to take 24 and I'm going to multiply it by the 1/6 t. I'm going to multiply it by the 1/8 t, and I'm going to multiply it to the 1. So if I multiply one piece to clear out my fractions, I have to multiply everything, all terms, no matter what. So if I take 24 divided by 6 is 4, times 1 is 4. So I'm going to move that over here. So that gets us 4t. Okay, so that's 1/6 of 24. It's just 24 divided by 6 times 1. And then 24 divided by 8 is 3, times 1 is 3, plus 3t equals 24. So that together makes 7t. If I combine my like terms, equals 24 divided by 7. I get t to equal 24/7. That doesn't mean a whole lot for time, but I can do 24 divided by 7. 7 goes into 24 3 times, which is 21, and I would have 3 left over. 3/7 of a minute. So if those two pipes work together, it's not just like kind of averaging it, right? Like, and some people would think, well, if you just average that, or you cut that one in half and cut that one in half, so that'd be a 3 and that would be an 8. So sorry, 3 and 4, if you average those two, is 3.5. It's kind of close, but it's not quite perfect to that. And it never will be, but it'll always be pretty close to cutting these two in half and then averaging it. We'll give you a ballpark, but it won't give you the exact. You'll have to actually do a little bit of work for it. Okay. So that was solving a problem, and that's definitely one of the more challenging problems of you have multiple people or machines or pipes or whatever doing the same job, okay, which does reduce the time. You're trying to figure out by how much. All right, last little bit we have is if you have some decimals in a problem, just like if you have fractions, like here we cleared out fractions by finding the least common denominator. Here we're going to multiply by however many decimals you have. So let me elaborate a little bit on that. This equation has the most number of decimals it has is 2. So we're going to multiply, because we have 2 decimals, 2 decimals, we are going to multiply to clear it out by 100. If your biggest number of decimals was 3, then you'd multiply by 1,000. So if you multiply every single one of these pieces by 100, 0.38 plus 100 times 1.1y equals 100 times 0.6. If you multiply every single one of those pieces by 100, all it's going to do is just bump your decimal over 2 spots. So that one's going to become 38. Write that over here so I can solve it. 38. This one's going to bump your decimal 2 spots and make it 110. Why? Right, because I got to fill that gap that I'm going to get here. And then this one's going to bump it over 2 spots and make it 60. So just like fractions, I don't have to deal with decimals at all. I can actually clear them out. But it's all based on the value that has the most number of decimals. So now I'm going to take that 38, I'm going to subtract it over to the other side. Oops. And then I can solve. So I have 110y equals 60 minus 38, which gets me 22. I divide by 110, and that gets me, if I throw that into a calculator, I get a 0.2. Okay, so just like fraction problems, clearing out fractions doesn't change the fact that your final answer might still be a fraction, which we had here. So if you have a decimal, clearing it out doesn't change the fact that you still might have a decimal. All right, last problem. What is the formula for simple interest? Not compounding interest, but simple interest. Simple interest is I equals your interest equals your principal times your rate times time. Okay, principal represents your initial amount. Rate represents whatever interest rate that you're earning. Here it is. And time is just the amount of time that it sits in whatever account. Okay, so you have $1,000 invested. So that is your principal is $1,000. Your rate, we want the decimal version of 6.25%, so 625. And then our time is 2.5 years, so we'll make that 2.5. So we'll make them all decimals to make it a little easier to just throw in the calculator. Okay, so this one's very straightforward. You have your amount, so $1,000 times your rate of 0.0625 times time of 2.5. Okay, so if you throw that all into the calculator, let the calculator do its thing, this is going to tell you that you're going to get $156.25 in interest. Now, this is not compounding interest. Compounding interest is interest earning interest, and this is not happening like that. So you're not going to get as much as if your interest compounds. So that's a different formula, different situation. This is the simplest of them. Okay. So that's it. So we had a couple problems. The most challenging one was two things kind of working together. How does that reduce the time? And if you have decimals, you can clear it all out, or you can just kind of use calculator to deal with the decimals. Doesn't matter, up to you. And then we have a new formula of how to find simple interest. That's it.